Hello student, today we are going to learn 11.2 example problem. It's from NCERT Physics class 12. It's from the photoelectric effect. If you like my channel, please subscribe. Okay. The thing is they are telling us a work function. I am taken work function is 2.14 eV. Work function is symbol is like this. Okay. We'll be learning everything. Okay. The question is asked. First we'll see what is the question is asked. I am going to solve with explanation. A is called frequency. What is how much frequency? Which is called threshold frequency. Frequency. Next one, wavelength is how much for incident light. Okay, wavelength is how much for incident light. Okay, it is a tricky question. The voltage is applied 0.6 volt. Okay, first we will learn 1 EV is how much joule. 1 EV is equal to 1.6 into 10 power minus 19 joule. This also you require to solve this problem. You have to do the problem with EV or joules. Okay, in this problem definitely you should find the joules because they asked wavelength. Okay, when they asked the energy alone, you can use the EV formula. Okay, so I will do one by one. First, frequency they asked. How much is the frequency? Okay, threshold frequency. See, first you need to know what is threshold frequency. So we have photoelectric material. When the incident light, it is incident. Okay, incident light is incident on the metal plate. Okay, some energy is going to take it as a work function, then electron is going to emit as the kinetic energy. Okay, work function, no, minimum energy is required to emit the electron or minimum frequency is required the electron to emit. That's we can take it as a threshold frequency. So they asked what is the frequency of threshold. Okay, so from work function only we can find. Already work function is given in the question. Okay, so work function is equal to 2.14 eV, which is given in the question. Okay, so work function is the minimum energy required to emit the electron or minimum frequency which is required to electron. Okay, emit the electron. So this we can take it as frequency naught, which is going to be the threshold frequency. Energy, everything is energy. Okay, it's going to be 2.14 eV, electron volt. So we want threshold frequency, it's going to be 2.14, EV is going to be 1.6 into 10 power minus 19. Definitely we should do this problem is in a GV. EV, H I am bringing as a denominator. H is going to be the Planck constant 6.63 into 10 power minus 34. It is frequency, SI unit is going to be the hertz. Okay, if you are doing this full calculation, if you are taken this as numerator plus 34 will come, then normal calculation only. If you are doing this calculation, finally you will get what is the threshold frequency. Threshold frequency is equal to 5.16 into 10 power plus 14 hertz. Okay. The next question, see here what is the incident light wavelength. Okay, now only you will be understanding the question properly. Okay, so as I already said, incident light, work function and emission of the electron. Okay, so total energy is coming from the incident light. It's going to divide into two things, work function plus kinetic energy of the electron. Okay, if you are taken work function as a here, incident light minus work function is equal to EK. EK means kinetic energy of the electron. So in this question they are given voltage as applied is 0.6 volt. Okay, so we need to know voltage to the EV. It is 0.6 volt is given, no, directly 0.6 EV you can take it. That's the energy only. Okay, volt into electron will be EV. Okay, so now I know this value, it is in a EV 0.6 EV. I know this value, it's going to be 2.14 EV, which is given in the question. So now incident light I am taken as a energy H frequency. Okay, it is incident light frequency, but we don't want incident light frequency. Wavelength only we require. This I am taken from here to here, minus is going to become as plus 0.6 plus 2.14 EV. So same unit only you can add. This addition will be, it's going to be 2.74 EV. This side I'll get H frequency. Okay, next step, I should convert frequency to the EV. C is equal to wavelength into frequency. So if you want frequency, C divided by wavelength. So frequency is C divided by wavelength. So H times of C divided by wavelength is equal to 2.74 EV. So 1.6 into 10 power minus 19 joules. Other than energy, remaining everything, EV you should convert as a joule. We are finding wavelength. So it's not a energy. Okay, you have to convert from EV to the joules. Okay, wavelength you can take it this side, this you can bring it here. So H is 6.63 3 into 10 power minus 34, C value 3 into 10 power 8, okay, this I brought denominator, so 2.74 into 1.6 into 10 power minus 19 is equal to wavelength will come this side, okay. So this whole calculation I'll get finally what is the wavelength, okay. The final answer of the wavelength is going to be 454 nanometer. Otherwise, you will get 454 nanometer is 10 power minus 9 meter. Otherwise, like this you will get. Otherwise, 454. Sometime the problem will be doing in angstrom unit also. Minus 10 meter. The same value 4540. It's an angstrom. Okay. So thank you for watching my channel. If you like my channel, please subscribe. All the NCERT example problem I'm doing in a playlist. Please check it in a playlist. All the example problem it's available. Thank you for watching my channel. If you like my channel, please subscribe.